You may already know hydrogen as the H in H2O, but did you know it's actually the most abundant chemical element in the universe? And on Earth, too. Hydrogen's natural abundance is why its potential as a source of green energy is so exciting. Hydrogen is extremely versatile and can be used in place of fossil fuels in industry, transport, power, or to heat our homes and businesses. Currently, nearly 80% of U.S. energy comes from fossil fuels. In a net zero future, we will have significantly more clean electricity, and many end uses will also shift to using electricity, like cars and heaters. But we are likely to need clean fuels, like hydrogen too. When we burn hydrogen or use it in fuel cells, water is the only byproduct. So it could make a huge difference to our carbon emissions and will be critical to achieving net zero. To use hydrogen as an energy source, we need it in the form of a gas. We rarely find hydrogen gas in nature, but we have a few different ways of producing it. Gray hydrogen, produced by breaking down natural gas to release the hydrogen it contains, is currently the most common, but it fails to capture the carbon emissions produced in the process. While less common, blue hydrogen is in use and could be scaled up. It's produced in the same way as gray hydrogen, but uses carbon capture and storage to prevent emissions, making it a low-carbon option. Green hydrogen is a completely carbon-free option. Green hydrogen is produced using clean electricity from renewable sources to split hydrogen from water, so no greenhouse emissions. And producing more of it in the future will help us reach net zero by providing long-duration storage, helping to integrate renewables, and helping to decarbonize sectors that are difficult to electrify. But once we produce it, we still need to get it to people who can use it. The U.S. already has an extensive gas network in place, so we're looking at whether we could use that. Leveraging the existing network could be the cheapest way to transport hydrogen, but it will take some work. Hydrogen and methane gases have some important differences, so we need to test how the network will perform, and we may need to adapt the parts or processes we currently use. National Grid is studying its system, working with the U.S. Department of Energy and Stony Brook University to test hydrogen blend limits in natural gas networks, so that one day in the future we could use cleaner fuels like hydrogen to heat our homes and businesses, and you could see hydrogen-ready boilers and ovens in your home. National Grid is also partnering with Standard Hydrogen to demonstrate the nation's first multi-use renewable hydrogen storage and delivery system in New York, with completion expected by 2024. The system will produce and store hydrogen exclusively from purchased renewable power and will safely offer market-based, zero-carbon energy services that support electric service, heating, zero-emissions vehicle services, and commercial gas service, all from one system at one site. As a versatile, clean fuel, hydrogen can play a role in enabling a net zero future.